Hello, Precalc. This is 2.7, solving equations in one variable. We're going to start by solving rational equations. And as we all know, rational equations are basically fractions with a function on the top and a function on the bottom. And when we solve these, they're equal to 0. So the zeros of this equation are just going to be the zeros of f of x. Keep in mind we don't want g of x to equal 0, whatever these zeros turn out to be. Plug it into g of x. If it equals 0, that is not a solution. So we'll start with example 1. X plus 3 over x equals 4. So you see we have this rational term right here with x in the denominator. We first want to take the least common denominator, the LCD. Alright. So all the denominators on this, the denominator under x is 1, under 3 it's x, and under 4 is 1. So our LCD for this one is going to be x. So what we want to do is make all of our denominators to be x. So I'm going to take x, I'm going to multiply it by x on the top and the bottom. 3 over x already has the x, I'm not going to do anything to that. And then 4, I'm going to multiply by x, top and bottom. Alright, simplifying this out, that's x squared over x plus 3 over x equals 4x over x. Now that all my terms have a common denominator, I can multiply everything by that denominator, essentially canceling out all my denominators. So I'm left with this x squared plus 3 equals 4x. And this is a quadratic equation, so I need to set this equal to 0. So I'm going to subtract that 4x over. And I believe I can factor this. So I'm going to try to factor. So factors of 3 that add to be negative 4. And that's going to be negative 3 and negative 1. Set each factor equal to 0. So x is going to equal 3 and 1. Now we might think we're done. We think that 3 and 1 are our solutions. We have to make sure they fit back into the equation and actually will equal 4. So let me try with 3. We got 3 plus 3 over 3, which is 1. So 3 plus 1 is 4. So 3 definitely works. Let's try with 1. 1 plus 3 over 1, which is 3. That also equals 4. So these are both solutions. If one of these did not work, that would be an extraneous solution. And that would not be a solution to your equation. Alright, so after you go over this first example, I want you to try exercises 1, 2, and 6. So I'm realizing that you might need to see example 2 before you try 1, 2, and 6. So let's do that. So we got x plus 1 over x minus 4 equals 0. So we need the LCD, least common denominator. Under that one is 1, under that one is x minus 4, and 0 we really don't need to worry about. So between 1 and x minus 4, they both need an x minus 4. So I need to multiply x by x minus 4, top and bottom. And that x is going to distribute. So we'll think of that as like having parentheses around it. Maybe not. So we got x squared minus 4x over x minus 4 plus 1 over x minus 4 equals 0. And like the first example, if the denominators are all the same, just cross them out. So we'll have x squared minus 4x plus 1 equals 0. And we can't factor this. Factors of 1 won't add to equal negative 4, so I'll have to do a quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2a. Simplify that out. So we got 16 minus 4, that's a 12 over 2. Root 12 has a 4 inside it, so a 2 is going to come out, leaving 2 root 3. Both of these terms are divisible by 2, so I'm going to reduce this down to 2 plus or minus 1 root 3. If I plug both of these back in for x, we will equal 0. What we're really looking for is if we get an x equal 4, which we can't equal here. And sometimes that will happen, you'll get an extraneous solution there. Alright, let's do example 3 while we're at it. Hopefully you see an extraneous solution here, just so you get the idea. We'll have 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Now this one's a little difficult to see what your least common denominator is, so I'm going to start by factoring this quadratic first. Maybe it'll be more clear. So factors of 3, they give us negative 4, and that's x minus 3 and x minus 1. So this one has x minus 3 and x minus 1. This term has x minus 3, this term has x minus 1. So our LCD here is going to be x minus 3, x minus 1. So I'll have to give this first term x minus 3, top and bottom, and the second term will need x minus 1. So let's do that. X minus 3 times 2x over x minus 1, x minus 3. 1 times x minus 1 over x minus 1, x minus 3 equals 2. X minus 3, x minus 1. All our denominators are the same. Say goodbye. Right, 2x is going to distribute into there, so 2x squared minus 6x plus 1 is going to distribute. X minus 1 equals 2. We got a quadratic, so I got to subtract my 2 over and simplify these x's. So 2x squared minus 5x, subtracting 2 over here gives us a negative 3 equals 0. And we can factor this, or we can do the quadratic formula. I'm going to choose to factor. So we need factors of 6 that give us negative 5. And when we do this, we start with 2x in each factor. And I know this isn't mathematically correct, but you'll get the right answer anyway. So negative 6 factors that give you negative 5. It's going to be a negative 6 and 1. So we'll go minus 6 plus 1. Notice we can take a 2 out of this factor. So take it out, but don't put it in front. We're really just kind of throwing that away. So this becomes x minus 3 and 2x plus 1. Alright, so that is this quadratic that's factored. You got 2x squared, you got negative 6x and 1x, that gives you negative 5x, and negative 3 times 1 is negative 3. Alright, setting each factor equal to 0. This one will give you 3, this one will give you a negative 1/2. Now, this is where we're going to see the extraneous solution. Notice what x cannot equal up here. It can't equal 1 or 3. So this solution here is going to be extraneous. And chances are on your test you're going to see an answer say 3 and negative 1/2. That is incorrect because 3 is not an answer. Just negative 1/2 is your solution. Alright, now you should probably go and try 1, 2, and 6. Alright, so for example 5, we have a word problem. How much pure acid must be added to 50 milliliters of a 35% acid solution to produce a mixture that is 75% acid? So this is a mixture problem. And usually you want to take a mixture problem with this formula. You want to go amount times the percentage plus amount times the percentage equals total amount times the final percentage we need. Alright, so we can start plugging this in. How much pure acid? So pure acid is going to be 100%, and we don't know the amount. So how much pure acid is going to be X and 100%, which essentially is just 1. Plus, so we're adding it to 50 milliliters, so we got 50. We'll just know that our amounts are in milliliters. And 35%. And our final amount has to be these two amounts added up. So our final amount is going to be X plus 50. And our final acid percentage has to be 75%. Okay? Now to make my life easier, I am going to multiply all of these terms by 100, essentially getting rid of these percentages. So this is now 100 times X, 35 times 50, and 75 times 50 and X. So let's go 100X plus and 50 times 35. Let's take a small break. I need a calculator. I'm back. 1750 equals, and I want to distribute this 75, so 75x plus 75 times 50. We get 3750. And now it's just a simple algebra problem. Let's solve for x. So I'm going to subtract 75x. I'll get 25x, and let's subtract 1750, and we'll get 2000. Divide by 25, x is 80. And remember, we are in milliliters, so let's give it the correct units. Alright, so let's give you some mixture problems here. Looks like the only good one is number 32. Oh, and 31. So do 31 and 32. Alright, last example. We're going to do example 6. This is finding a minimum perimeter. So we want to find the dimensions of the rectangle with a minimum perimeter if its area is 200 meters squared. So we got a visual aid here. It's a rectangle, and we know that its area is 200 meters squared. Now we all know the area of a rectangle is length times width. So let's give this length, let's give this width, and plug in 200. For the area. Alright, we also need to get the perimeter. So let's get the perimeter formula here. And that's going to be 2 of these lengths plus 2 of these widths. So 2L plus 2W. Alright. And we're going to actually solve for perimeter here. So let me just solve for one of these variables here. Let me solve for L. Alright, so L is going to be 200 divided by W. So I'm going to plug that in for L right there, just so that the perimeter is all in one variable. So 2 times 200 divided by W plus 2W. So we got 400 over W plus 2W equals the perimeter. And we want to graph this. We want to figure out where its minimum is. So we're going to graph 400 divided by x plus 2x. Alright, so we can't see this. So we got to zoom out. Alright, still can't see it. There it is. So we want to know where its minimum is. So we got to find that point. So we want to second trace minimum and go to about that point. Left bound, right bound, and guess. So our W equals 14.14. Alright, plug that back in to the equation up here. So L is going to be 200 divided by 14.14. I'm recording a video right now. Can you chill for like a second? So L also equals 14.14. And this is in meters. Alright, so this essentially is a square. That's going to give you the least perimeter.